Question 9. Let's have a look at this then. That point's on the curve. So here's 6. 6 is equal to 3 times 12 to the x, which is k. So that tells us, divide by 3, 2 is equal to 12 to the k. So that tells us that k, drop the 12 down to be the base, log 12 of 2. Let's just tap that in then. Log 12, base 12 of the number 2. 0.279 to 3 significant figures. 0.279. And that was the 3 significant figures. That was part A. Part B, area, approximately equal to. Now H is B minus A. 1.5 minus 0 is 1.5. Over 4 ordinates, so that's 3 strips, so N is 3, which is 0.5. Okay, so it's 0.5 times this stuff here, 3 strips, 4 ordinates, so we got x0, x1, x3, 0 to 1.5. When we're up in 0.5s, aren't we, divided by 3? And then we get y0, y1, y3. So put 0 into our formula. 3 times 12 to the x. Put x is 0 in, 12 0 is 1, that's 3. Put, this is 3 root 12. This is 3 12s is 36. And this is 3 times 12 root 12, which is 36 root 12. Okay, so we get y0 plus yn, 3 plus 36 root 12, plus 2 lots of the things in between, 3 root 12 plus 36, which equals 0.5 times bracket 3 plus 36 times root 12 plus 2 times open bracket 3 times root 12 plus 36, close that bracket, close the bracket for everything, equals decimal 110.24. 0.24, and we had to work that out to 2 significant figures, which is 110. Okay, so that's B. Okay, so this is translated by 1p, so it's y minus p is equal to 3 times 12 to the x, which is x minus 1. That's the translation equation. So given f0 is equal to 0, so y is equal to p plus 3 times 12 to the x minus 1 at 0, 0. We got 0 equals p plus 3 times 12 to the minus 1. So that tells us then that p is equal to minus 3 over 12 minus 1/4. Find p minus 0.25. Yeah, I just checked, that seems okay, but one slight change from here. Basically, this should have been h over 2. So h is 0.5, so this is a quarter here, not a half. So that would have worked out half of that over 2, which is 55. So that's just 55. Sorry about that, apologies for that. So I've corrected it now in hindsight. So I've done C to work out that. Now part D in the question. Let's have a look at part D. Here, there is a part D, there we go. At the point T, should it? Okay, where Q is an integer, state the value of Q. This intersects this curve at T. So when does that equal that? And solve for X. We want to find X, state the value of Q. So when does part D, 2 to the 2 minus X, when does that equal? 3 times 12 to the X. 3 times 12 to the X. Okay, so what we're going to do here, we could take logs and get everything down on ground level. 2 minus X log 2 is equal to log 3. And then log plus another log, but this can be written as X log 12. So what have we got here then? So we've got 2 log 2 minus X log 2 is equal to log 3 plus X log 12. So move this X to be with that X and move this over to be with this. 2 log 2 minus log 3 is equal to X, move that over, and then you'll have log 2 plus log 12. Let's just have a look at the paper. Okay, 2 minus 2 log, log base 2. Okay, they've done log base 2. That's interesting. So I have to use log base 2. So this log can be to any base. So let's have a look again. Log 2 of 3 and log 2 of 3. Okay. So X is equal to then 2 log 2 of 2 is 1, so X will equal 2 minus log 2 of 3 over, this goes underneath, doesn't it? So it would be 1 plus log 2 of 12. And log 2 of 12 is 3 times 4. So that would be log 2 of 3 times log 2 of 4, which is 2, so that would make that 3. Hope you saw that then. What I did was I took the 12 and it was 3 times 4, so I left the log 2 of 3, but the times 4 I did plus log 2 of 4, which is 2. 2 plus 1 is 3. So what did we get when we look back? Plus Q log 2 of 3. Q equals 3.